Let's take a look at this 10-mark question that was in today's KZN paper. 50 cm cubed of a solution of dilute HCl is added to 25 cm cubed of 0.075 mole per dm cubed sodium carbonate at 25 degrees Celsius. The HCl is in excess. The concentration of the excess HCl in the resulting solution is 0.013 moles per dm cubed. Calculate the pH of the 50 cm cubed HCl that was initially added, and basically assume that the temperature doesn't change at all. Now they've given us the balanced equation, and they want us to calculate this, worth 10 marks. Now the important thing to remember is that the number of moles of HCl that we had at the beginning is basically going to be allocated in two different places. So let's just draw a little diagram here. So at the start, the number of moles of HCl is going to be used for the reaction, and the other part of it is going to be used, or it's just going to lie in excess. And the idea here is to calculate the number of moles that was used in the reaction, calculate the number of moles that was used in, or that was lying in excess, add it up, convert it to a concentration, and then calculate the pH. So it's not too dissimilar to other types of questions that have been done before. But let's take a look at it. So the first thing we'll do is let's focus on how much was used in the reaction. So to do that, we'll start with our base. The number of moles of the base is going to equal the concentration times the volume. Concentration was 0.075. The volume was 25 over 1,000. And that's going to give us 1.875 times 10 to the negative 3 moles. Now from here we can do a mole ratio. The ratio is 1 to 2 to figure out the number of moles of HCl. So the number of moles of the acid is going to be double since it's a 1 to 2. And that's going to give us 3.75 times 10 to the minus 3 moles. So that's the first part done. So 3.75 times 10 to the negative 3. Now let's figure out how many moles is in excess. So in excess, we know the concentration and we know the volume. So to calculate number of moles, it's going to be concentration times volume. So concentration 0.013, and the volume is additive. Remember, this is at the end. So the total liquid of the acid and the liquid of the base are going to be joined. So we're going to have 25 and 50, so 75 cm cubed. So 75 over 1,000. And that's going to give us 9.75 times 10 to the negative 4 moles. So we have this. So 9.75 times 10 to the negative 4 moles. So we have that. And if we add them up, we'll get the number of moles at the start. So number of moles at the start is going to equal 3.75 plus 9.75 times 10 to the negative 4. And that's going to give us 4.725 times 10 to the negative 3 moles of my acid. And remember, at the beginning, the acid was in a 50 cm cubed liquid. So the concentration is going to be 4.725 times 10 to the minus 3 over 50 over 1,000. And that's going to give us 0.0945 moles per dm cubed. Now remember, HCl is monoprotic. So the concentration of the HCl is going to equal the concentration of the H3O+. So pH is going to equal minus log, and the concentration is 0.0945, and that's going to give us a pH of 1.024.